you are just one in over 7 billion people bustling about on planet Earth. Are you sat on a bus, maybe watching this in a traffic jam, or maybe you're already at home after a busy day in the office? So when was the last time you looked up at the stars in the night sky? In our own Milky Way galaxy, there are around 350 billion stars. That's 50 stars each for every single human being on planet Earth. And in the universe, there are over 100 billion galaxies. So we can be quite confident that as you gaze upwards, somewhere in the cosmos, someone is looking right back at you. We know some amazing things about the universe. We know that the chemicals that we're made up of could only have been formed in the hot, fiery core of a star that in its death throes created the gas cloud which our solar system then formed out of. In our own solar system, we know that as well as the planets, there are millions of killer rocks out there that might one day obliterate planet Earth. We know that the first galaxies in our universe formed over 13 billion years ago, and that the galaxies that we see today have a massive black hole at their centre. And now thinking on really, really big scales, we know that our whole universe is expanding, but mysteriously that expansion is getting faster and faster every day. But how do we know all this? Astronomy is the science of the largest distance scales, the longest time scales, and the most extreme environments in terms of temperature, pressure, and density. Now, unlike biologists and chemists, we can't create an experiment in a laboratory to test these extreme conditions. Astronomy as a science can only observe what the universe chooses to reveal, and that's through light. So, what's light? To answer that question, we need to think a little bit about fundamental forces. There are 4 fundamental forces in our universe, and the one that you're probably most familiar with is gravity. It's gravity that keeps us stuck to the ground. But what about electromagnetism? Got 2 magnets here. It's the force of magnetism that's pulling these 2 magnets together. Now, we say the force is carried by a field, and that's actually all that light is. Light transports energy by varying the local electric and magnetic force field. So as light leaves your computer screen into your eyes, what it's doing is it's varying the electromagnetic field, and that transports the energy into your eyes. So light transports energy, but there's lots of different types of light. There's the optical light that you're seeing me in at the moment, but I'm hot, so I'm also emitting an infrared light. Some of the most energetic objects in the universe, such as a massive supernova explosion, will emit so much energy that we'll see that as X-rays and gamma ray light. And maybe if you're listening to the radio, that's a very, very low energy light. Now, in order to understand the universe, astronomers have to observe in all of these different types of light. And in the next video, Andy's going to tell you about how we're going to do that.